Welcome students. In this question we are expected to find the coefficient of x raised to the power 3030, and we are given this expression 1 positive x squared positive etc positive x raised to the power 3030, which in turn is raised to the power 3031. Now when we see this particular expression, it might look very daunting, but what we can do is we can connect this to the most famous geometrical series. Now if you would have studied geometric series, you would have studied about this particular expansion 1 negative x raised to the power negative 1, which is of the form 1 positive x squared positive x cubed positive etc. It goes off to infinity. Now in this expansion there is another deduction that we can always obtain. Now that expansion is given of the form, instead of negative 1, what if I have negative n? So this is an expansion, and we know we have already studied expansion of the form 1 negative x raised to the power n. Now this is the famous binomial expansion. But what if n has a negative sign? So in that case the expansion is written in this following fashion: 1 positive nx divided by 1 factorial positive n into n positive 1 divided by 2 factorial times x raised to the power 2 positive n into n positive 1 times n positive 2 divided by 3 factorial, and that has to be multiplied with x raised to the power 3, and so on it goes. So what we are going to do is we are going to be using this geometric series expansion to solve the question. Now this is already been mentioned, 1 negative x raised to the power negative 1. Now what I'm going to do is I'm going to be rewriting this in this fashion. So how am I going to do that? Now clearly it says that we have to obtain the coefficient of x raised to the power 3030. Now definitely at some point we are going to encounter x raised to the power 3030. So what I'm going to do is I am going to be writing 1 negative x raised to the power, let it be on this side, 1 negative x raised to the power negative 1 to be as 1 positive x squared positive etc positive x raised to the power 3030 and positive x raised to the power 3031 positive etc. It goes on. It's an infinite geometric series. Now this is what we have got. Now I can suitably rewrite this to have the power of 3031. So how am I going to do this? Now if I were to expand, or I should say if I were to raise this to the power of, so this is 1 negative x raised to the power negative 1. If I were to raise this to the power of 3031, then this is nothing but 1 positive x squared positive etc. It goes positive x raised to the power 3030 positive etc. Now this is raised to the power of 3031. So now what I need to do is I need to suitably represent this using the studies we have obtained from binomial expansion, which is easily possible. Now this is nothing but this in disguise. So I can rewrite this to be equal to 1 negative x raised to the power negative 3031, which is of the form 1 negative x raised to the power negative n. Now clearly binomially I can rewrite this expansion in the following manner. So let me rewrite this. So this is going to be equal to 1 negative x raised to the power negative 3031, which is in turn equal to, now the idea is to obtain the coefficient of x raised to the power 3030, and the degree of n is given to be as 3031. So in this case, this is going to be n, you got to specify the degree n positive whatever k that you want. It doesn't matter whatever value that you need. So that k you can place here, and it has to be followed with a -1, and that is followed by n positive k -1 ck. So this is the coefficient that we can arrive at, and that has to be multiplied with x raised to the power k. Now the degree given for n is 3031, and the value of k that they are expecting us to obtain is 3030. So from here I can easily obtain the coefficient. So this is nothing but equal to sigma, the value of n 3031 positive 3030 -1 and 3030 times x raised to the power 3030. So this is going to give me the coefficient. So what is that? Now I can add 3031 with 3030. So that is going to give me 1606, and from here I need to remove 1. So that is going to be equal to 6060. So this is equal to sigma 6060 c k is 3030. So this gives me the coefficient x raised to the power 3030. Now nck. So nck is equal to n factorial divided by k factorial times n minus k factorial. So this is equal to, so from here 6060 c 3030, this is going to be equal to nck 6060 factorial divided by 3030 factorial times 6060 negative 3030. So if I were to subtract 6060 and take away from it 3030, this is going to be 0, this is going to give me 3, this is going to be 0, and I get 3030. So this is equal to 6060 factorial divided by 3030 factorial times, and of course I have a factorial here, so this is going to be 3030 factorial. So this is what is the coefficient